Here we have a question based on polar coordinates. Identify the curve which is given in the polar format. So these are polar equations by finding their Cartesian equations. So the problem is to first convert them into Cartesian equation. Okay. And then identify the curve. So I want to remind you guys that we have some basic relationship between x, y variables, which are Cartesian, and r and theta. So x is equal to r cosine theta. That's the first relationship. Y is equal to r sine theta. And reversely, we have r square is equal to x square plus y square. And tangent theta is equal to y by x. Please remember these relationship between polar coordinates and the Cartesian coordinates. So now we're going to work on one at a time problem. Part A. It says r square equal to 5. What is r square? From our relationship, that's x square plus y square. So that's going to be x square plus y square equal to 5 by replacing r square by x square plus y square. Okay. Now, in geometry, we know our equation x square plus y square is equal to a square is a circle with center at 0, 0 and radius equal to a here, right? Now you can see this is 5, that can be written as root 5 square. Therefore, this thing is a circle with radius root 5 and center at 0, 0. And you can easily draw the graph of this. That's going to be a circle with center at 0, 0, which is origin, and your radius is root 5, square root of 5. That's our first part, okay? So we identify r square equal to 5 as a equation. First of all, we convert that into Cartesian equation using our first relationship between r square and x square and y square. Let's work on part B. Theta is equal to pi by 3. Now, here we are going to use the second one. So we can take tangent on both sides. Tangent theta is equal to tangent pi over 3. We know that tangent pi over 3 is root 3. And from our formula, we know that tangent theta can be written as y by x. So we can write our equation as y by x is equal to root 3, which can be also written as y is equal to root 3x. So this is your Cartesian equation for the given polar equation, theta equal to pi by 3. So what does that look like? That look like your equation. How will be the curve? That look like equation of a line, which is you can call it diagonal line passing through origin and have slope as root 3. Okay, so how will it look? How will the graph look? That's going to look like a line which passes through diagonal at the angle pi by 3. That is the equation of either this polar curve or this Cartesian equation. Both of them are exactly same thing. They are just written in two different systems. Let's work on part C. R is equal to 5 cosine theta. These ones have to be done a particular way. The first step is multiply both sides within by r. So that's going to make it look like r square equal to 5r cosine theta. Now we know r square is x square plus y square. So the left hand side can be written as x square plus y square equal to 5. We know r cosine theta can be replaced by x. So we have the equation, Cartesian equation, x square plus y square equal to 5x. So we're almost done. But from just looking at this, I don't know what the curve is. We need to identify the curve also, right? So I'm going to try to make this into a special curve by doing the perfect square technique. Okay, so I subtract 5x on both sides. The perfect square technique is, look at the coefficient of x. Okay, coefficient of x is 5, half it, and square it. That's going to be 25 by 4. So we're going to add 25 by 4 on both sides of the equation. So 0 plus 25 by 4 on the other side is that. Now you can collect this much. That's going to look like x minus 5 by 2 whole square plus y square equal to, the right hand side is 5 by 2 whole square because it's 25 by 4, right? I want you to compare this equation with x minus a whole square plus y minus b whole square equal to r square, which is a circle with center at A, B, and radius equal to r. Now, using that comparison, what is this equation? That is circle with center at 5 by 2, 0. You see, in place of A, we have 5 by 2. In place of B, we don't have anything, that's 0. And radius is equal to the right hand side 5 by 2. That is our curve. Okay, in that knowledge, we should be able to draw a little curve for that. So on x and y axis, right, we have our center at 5 by 2, 0. So let's say this is 1, 2, 3. 5 by 2 will be somewhere here. And 5 by 2, 0 is your center. And the radius is this much. So we have a circle with center at 5 by 2's. This point is 5 by 2, 0. And the radius also is 5 by 2 on both sides.